ඒ තරම් ඇඳුන්නේ නේ.
පුතලා කොහොමද? good morning. ඇහෙනවද?
Yes,
good
sir.
morning
Good morning,
තමයි.
sir.
ඔව්.
Good morning, sir.
Good morning, sir.
good morning. very good morning. කොහොමද වැඩ හිම?
Sir, මේ exam එක කොහොමද දන්නේ?
පුතා තාම එක්සෑම් එකට නම් ඔය කට්ටියට දවස් තියෙනවා. මේ
Sir, physical ද තියෙන්නේ?
බලමු පුතා කොහොමද කියලා. තාම ඒ ගැන ඩිසිෂන්ස් අරගෙන නැහැ කිසිම දෙයක්. ඔව්. අදත් හරිම ඉම්පෝර්ටන්ට් පාර්ට් එකක් ඔය කට්ටියට කොහොම හරි මේ සබ්ජෙක්ට් එක කියලා දෙන්න ඕනේ. මේ වුණාට ගොඩක් අය මේ ක්ලාස් එකට එනවා. ඉතින් ඒ කට්ටියට ටිකක් අමාරු වෙනවා ඉස්සරහට. වැඩි. එක්සෑම් එක තියෙයි කොහොමද අනිවාර්යෙන්. දැන් යන විදිහට ප්‍රැක්ටිකල්ස් එහෙම පස්සේ කරන්න හරි පුතා මේ එක්සෑම්ස් කලින් තියෙන තත්ත්වයක් තමයි තියෙන්නේ. ඒ වගේ වෙයි මට හිතෙන්නේ. සමහර ඩිපාර්ට්මන්ට්ස් වල උදාහරණයක් හැටියට මැනේජ්මන්ට් ඉන්ඩස්ට්‍රියල් මැනේජ්මන්ට් කියලා තියෙන එක.
ඔව් සර්.
සමහර මං කරන ලෙක්චර්ස් වලට මේ කියන්නේ විභාගේ වෙනද විදිහට තියන්න බෑ කියලා කොහොමද තියන්නේ කියලා එහෙම ඉතින් අහලා වෙලා තිබ්බා. ඉතින් අපි ප්‍රොපෝස් කෙරුවා වයිවා එකක් ප්‍රසන්ටේෂන්ස් අරව මේවා ඉතින් ඒ වගේ මේ මොන හරි ඕල්ටර්නේටිව් අපිට අප්‍රෝච් එකක් ගන්න පුළුවන් සබ්ජෙක්ට් එකට.
සර් මැත්ස් පාර්ට් එකක් තියෙද්දි කොහොමද සර්?
මැත්ස්ද?
ඔව් සර් මේ මැත්ස් පාර්ට් තියෙනවනේ සර් මේ දැන් අපිට කරන හැම සබ්ජෙක්ට් එක වගේම සර්. එතකොට
බලමු මේකට කොහොමද කියලා නේ. පුතා අපි තාම ක්ලාස් එකේ අපි ගෲප්ස් වගේ හදාගෙන නැහැ. in any case කියලා කෝකටත් අපි groups ටිකක් ෆෝම් වුණා නම් හොඳයි. groups ටිකක් ෆෝම් වෙලා ලීඩර්ස්ලා ටිකක් දාගෙන ඒ විදිහට මොකද ඉස්සරහට මොන හරි ප්‍රසන්ටේෂන්ස් හරි මොන හරි කරන්න වුණොත් එහෙම group වගේ හැදුනා නම් හොඳයි. ඔව්. බලමු කොහොමද කියලා නේ. Kaya di. Kami ni close din ay. කොහොමද ඔය පැතිවල කොරෝනා එහෙම තියෙනවද කොහොමද? දන්නේ කොහොමද කියලා. කොහොමද පුතා තත්ත්වය? කොරෝනා තියෙනවද දැන් ඉවරද ඔය පැතිවල කොහොමද? ඔය කට්ටිය නම් කොළඹ හයි නෙවෙයි වෙන්නේ නැති නේද ගොඩක් ඉන්නේ පුතා. මමත් ඉන්නේ කොළඹින් පිට. පුතාලා කොහොමද උගන්වන්නේ ඒවා ඔය කට්ටිය ෆලෝ කරනවද ඉෂුස් තියනවද කොහොමද තත්ත්වය සාමාන්‍ය කියන්න බලන්න කවුද ඉන්නේ බිම්සර ඔව් පුතා කොහොමද මේ සබ්ජෙක්ට් එක උගන්වන එක තේරෙනවද Zoom එකෙන් අපි එක්සැම්පල්ස් ටිකක් එහෙම ඉස්සරහට කරන්නම් කියලා ඉන්නේ කොහොමද සීනෝන එක්සැම්පල්ස් ඒ දැනට තියරි ටිකයි ඔය කට්ටිය මම හිතනවා නෝට් එක ෆලෝ කරනවා කියලා හරියටම ඒත් එක්ක මේ අපේ Zoom session එකෙන් ලොකු ඇඩ්වාන්ටේජ් එකක් ගන්න ඕන ඒකයි බිම්සර කොහොමද ඔව් කියන්න පුළුවන්ද කොහොමද කියලා පුතා Zoom එක ඔන් කරලා ගිහිල්ලාද නැත්තම්
Good morning, sir.
ඉන්නවනේ මේ සබ්ජෙක්ට් එක කොහොමද පුතා තේරෙනවද
Oh, sir.
තේරෙනවා නම් හොඳයි තේරෙනවා නම් හොඳයි මමත් බලන්න පුළුවන් තරම් නැචරලිව කියලා දෙන්න කියලා බලන්නේ
Oh, sir.
එතකොට කවුද වෙන්නේ කේශල පුතා කොහොමද කේශල අරවින්ද
Hello, sir. Good morning.
good morning කොහොමද ඩිෆිකල්ටිස් තියෙනවද ඔන්ලයින් යන්නේ ඊට පස්සේ සබ්ජෙක්ට් එක රිසීව් වෙන විදිහේ ගැටලුම් තියෙනවද
ගොඩක්ම නම් ගැටලුත් නැහැ උනාට සාමාන්‍යයෙන් ගැටලුත් තියෙනවා සර්.
ඔව් නේ ගැටලු තියෙන එක හොඳයි ඒ වුණාට අර ඉගෙන සබ්ජෙක්ට් එකක් ඉගෙන ගන්නකොට ගැටලු කියපුවා මේක මේ හිතලා එන ගැටලුද එහෙම නැත්නම් මේ තීරුම් ඒවි තියෙන අපහසුතාවද චුට්ටක් බලලා ඒවා සෙටල් කරගන්න ඕනේ මොකද ඒක දැනුමට බාධාවක් වෙන ගැටලු පුළුවන් තරම් නිරවුල් කරගන්න ඕනේ පුතා මේකයි දැනුමට බාධාවක් වෙන ගැටලු බලන්න අපි බලමු ආයේ සඳරුවන් කොහොමද පුතා සඳරුවන් කොහොමද ඉන්නවද
Hello, sir.
ඔව් පුතා good morning කොහොමද සබ්ජෙක්ට් එක යනවා හොඳයිද ජොයින් වෙනවද හැමදාම
Join වෙනවා sir. ලොකු වරදක් නැහැ. ඉතින් අර දන්නේ නැති ඒවා යාළුවොත් එක්ක ෂෙයා කරගන්න බැරි අවුලක් තියෙනවා පොඩි.
ඒක තමයි නේ
ඔව්.
බලන්න පුළුවන් තරම් නොලෙජ් එක ගේන් කරන්න ඕනේ මොකද එක්සෑම් එකට අපි ටිකක් ස්ටෑන්ඩඩ් පේපර් එකකට අපි ෆේස් කරන්න ස්ටෑන්ඩඩ් කියන්නේ අමාරු නෑ වුණාට අර ටිකක් ඉතින් ක්වොලිටි පේපර් එකක් තමයි කට්ටියට හම්බ වෙන්නේ ඉතින් අර මූලික ලොකු අවබෝධයක් තියෙනවා ඒකයි විෂය ගැන තියෙන අවබෝධය කියන එක තමයි පුතා වැදගත් වෙන්නේ ඒකයි හරියටම හරියන්නේ සිංහල වචනෙටම අවබෝධය කියන එක මොහමඩ් කොහමද පුතා MK Mohammed any issues for you manufacturing the mechatronics there are you there Mohammed, are you there, Buddha? Okay, looks he has some difficulties responding maybe. We'll see. Oh. Last week we have done this. I believe you have received this note as well. Here, Buddha, you have to take note for this polytropic process. N equals 1. Yeah, we have a general expression for the work done when the process is taken place from 1 to 2, thermodynamics process. And polytropic general expression I mentioned here, P1 V1 minus P2 V2 by N minus 1. Later we will come for further when we do the examples. But this is for the range from N equals 1 to gamma. As I mentioned to you. But when N is equal to 1, W12, if you substitute 1 here, you can see N equals 1, this becomes 1 minus 1. 1 minus 1 is 0. That's why N equals 1, W12 expression, we cannot use this. Okay. So there is a special expression for this W12 at N equals 1. Instead of P1 V1 minus P2 V2 by N minus 1, we can have an expression, this is a very simple one, P1 V1 natural logarithm here, log V2 by V1, okay, log V2 by V1. This is not a difficult one, this is quite easy. So same way for the 1 to 2 expansion as well. So if you substitute N equals 1, here becomes 0 because 1 minus 1 is 0. Therefore, instead of using W12, this general expression, for this isothermal expansion, that is N equals 1, we have a different expression. Okay. And it is quite easy. It is not difficult at all. It is quite easy. So see your notes. Okay, check your notes. In the notes, all are explained. Okay, check your notes. That is very important. Looking at the notes. Right? Yeah. So gamma is, yeah, N is between gamma and 1. That's right. So 1 is isothermal. Yeah, it's mentioned here. N equals 1. Yeah. That is constant temperature. So there can be near isothermal processes. And also N equals gamma. So N can be anything in between these two. For the compression processes, I mean air compressors and all, closer to isothermal is better. I have explained it to you. Okay, closer to isothermal is better because compression process. So you should understand, let's say example, air compression. Okay, air compression. So your sole purpose is compress the air. Okay. In compressing the air, what's most important is to have a better compression effect with less effort. Compression effect is there, but with less effort. Effort means less work done. So during the compression of gases, if temperature goes up in this gases being compressed, if the temperature goes up, those gases have increased kinetic energies. Kinetic energy, so the work done has to be more to counter that increased kinetic energy. Compress කරනකොට හුලං අපි හිතමුකෝ ඔය හුලං ටික රත් වෙනවා නම් වෙන්නේ මොකද රත් වෙනවා කියන්නේ නිකන් අර කියන දේ අහන්නේ වගේනේ වයලන්ට් ගතියනේ එතකොට ඒව කම්ප්‍රෙස් කරන්න ලොකු ශක්තියක් ඕනේ උනාට ඒ හුලං සයිලන්ට් නම් වැඩි දඟලන්නේ නැත්නම් ඒ කියන්නේ low temperature නම් so you can have a better effect of compression තේරුණානේ අඩු මහන්සියකින් කම්ප්‍රෙස් කරන්න පුළුවන් එයා හරි ගෑස් හරි සයිලන්ට් නම් කියන්නේ low temperature low temperature කියන්නේ if there is a temperature initially T1 so T1 can be maintained we call it constant temperature or isothermal to run practical aspects thermodynamics ඉගෙන ගන්නකොට මෙහෙමයි වෙන්න ඕනේ පුතා first of course for analysis you need equations and all okay but for the essence of knowledge you don't need equations but that taking that essence of knowledge that is the biggest challenge taking the essence of knowledge එතන ලොකුවට maths නැහැ අන්න ඒ ටික තමයි දැනගන්න ඕනේ but many things that technology is maths that is not so තාක්ෂණ විෂයක් කියන එකක් හරියට ගන්න එකට තමන්ගේ ලොකු ප්‍රඥාවක් ඉම්ප්‍රූව් කරගන්න ඕනේ. ටෙක්නොලොජිකල් විස්ඩම් එකක්. ඒක හදා ගන්න ඕනේ පුතා හිතලා. ක්ලාස් එකේ ළමයි හිටියා ඒ වගේ හිතලා ප්‍රශ්න අහන ළමයි හිටියා ක්ලාස් එකේ කියනකොට. I noted it really. හැම කෙනාම මේ පොටෙන්ෂල් එක හදා ගන්න ඕනේ පුතා. How to naturally understand these phenomena because phenomena belongs to nature. For analysis, of course, we have to look into equations, some mathematics, some models and all. That is secondary. Then go back to textbook secondary part. Primary part it is not that well explained. Well explained karla nahi samahar puttul nahi but not that explained. Explain karla nahi tika somehow you have to gain it. And this session is a helping hand for that. මේ session එකේ ඒකට අත්උදව්වක් තමයි දෙන්නේ පුතා. ඊළඟ විෂය තේරුම් ගන්න. ඒක හරියම වැදගත්. You have to go hand in hand with these Zoom sessions together with your notes. තරමක වෙහසක් ගන්න ඕන කට්ටියට. So now you have to have a little bit effort on this to have that technological wisdom එකක් තමන් හදා ගන්න ඕන. Imagination එකක් වෙන්න පුළුවන්. Ideas, oh, those are very important. Earth removing project, can you remember? Yeah, remember earth removing project? Not a guide. No. So we are going to continue from here. We are going to continue from here. කල්පනා කරලා බලුවද ඒක? Okay. So how you are planning this? Okay. Let's say how you are planning this. So excavators, backhoes and dump trucks you need. Okay, to remove this earth. So I'm going to put some photos here. Give me a second, Puta. Give me a second. පුතා පොඩ්ඩක් ඉවසලා ඉන්න. Be patient for a while. I'm searching something. So you can see backhoes, some dump trucks, and then the excavated soil loaded to the trucks. Okay. So the excavated soil loaded to trucks. You can see some resources and how the process is being done. Okay. Then after that, you have to look for a dumping site. Then this loaded soil or loaded earth, excavated earth, should be unloaded somewhere in the dumping sites. Okay. Dumping site. Things will be unloaded. Okay. So, of course, from loading to unloading, there should be a kind of dispatch. Okay, dispatch means it's being transported, dispatched to the dumping sites. This loaded one, dispatched to the dumping site. So let's see dispatching. So this loaded ones dispatched to the dumping site means it's a kind of transporting should be done. The truck should be moved here. Okay, loaded trucks. So let me put a photo again. Okay, loaded trucks. So I will just put a photo. Transport, I will show a different shape of the truck. Okay. Transporting being done. Should be the same by right. Okay. Should be the same. Getting loaded, but anyway, this is the transport. This is the transport. Yes, so this is how it is. So these are working on the site. Then some are really collecting the soil and all. Then loaded to this transport and then unload, and after that the empty one should return back. So the empty transport, after unloading, the empty truck should go back to the dumping site. Okay, should go back to the dumping site. So there, again, you can see you have the loading. Okay, you have the loading. So the empty, go back to loading. So I put it here. Yeah. So then empty truck goes for loading again. Okay, goes for loading. So that's how it is. Okay, this goes for loading. Can you imagine this? Kamal. Good morning, Kamal. Lecture එකක ඉන්නේ Kamal. මං ගන්නද විනාඩි චුට්ටකින් වගේ හරි. Right, හරි. හරි. So this is how you should plan the resources and the process. Okay, this is how you should plan. So are you okay with this? So what are the steps here? What are the steps here? The real steps. Okay. What are the steps? What are the steps? Tell me. Then කතා කරුවට කමන්නේ පුතා. What are the steps?
Excuse me, sir. We can't hear, sir.
Yeah, Buddha. Okay. So if you think of the processes here, you can see this soil may be hard. So you have to excavate and collect the soil for loading. Okay, excavate and excavate somehow you have to, yeah, use this. Excavate should be okay. And collect the soil. For loading. Because without excavate, okay, without excavate, you cannot collect. Yeah, that's why you have the excavators for the excavation and backhoes for the load collection and loading maybe. So excavate is one. Okay, and collect the soil and collect the soil for loading. That is very important. You know it. So that's why you need the backhoes and something like excavators. Then in the loading you need loading means you have to transport it. For loading, to transport. Loading to transport the soil or earth. Transport the soil for the dumping site. Site or land, okay, or place, dumping place. So you can see excavate and collect. So see this backhoes, excavators do the excavation and collection. See the collected ones. Then you do the loading. After that, we have to transport this for the dumping site. Okay. Then you have to do unloading at the dumping site. Unload. Unload the soil from the truck. What is truck means? Transport. Okay, from the transport to unload it. Okay. Okay, unload. After that, empty truck or transport should return for loading. So that is the third one. Okay, empty truck or transport should return for loading. Empty or unloaded. Yes, empty means soil or earth unloaded. Truck or transport should return for loading. Should return for loading. Okay. So at the dumping site, this is the one. Okay, at the dumping site. Unload the soil from the truck. So first you have to do the excavation. So I put it here. For loading. For loading to transport the soil for dumping site. Then you have to have the transportation. Okay, so maybe I make a new slide there. New slide. Okay, then you transport the loaded, soil loaded trucks. Transport the soil load. Out from the construction site. Out from the construction site. Do the transportation. Okay, out from the construction site. Okay, At the dumping site, unload. Then after that, empty or unloaded truck or transport should return for loading. Okay, for reloading. Okay, for reloading. Reload නම් දන්නවනේ නේද? ෆෝන් කාඩ් එහෙම දාලා. For reloading. So you can see key. So here loading to transport is taken place. Loading the soil. What soil? Excavated soil and collected soil. So now the excavated and collected soil to transport for the dumping site. So yeah, good. So you can see how many steps here. Of course, excavation. So they have to, excavators, they have to do that job continuously. Okay, excavation. They have to do that job continuously. Okay, excavation. So some do this. Okay, some do this, excavate. So some, they do loading because the collected soil, loading the excavated and collected soil. So some are doing this. Okay, then to the truck. Then there are drivers, okay, employed for transporting. So the trucks are there, trucks are moving out. So they do their job. And unloading site, they unload it. So this unloading site also important. So after unloading, empty transport should return back. So you have to make sure. Empty transport should return back. මේක ගියේ නැත්තම් මගදී කොහාරි ගියොත් එහෙනම් මොකද වෙන්නේ? Yes. මගදී වෙන්නේ කොහාරි ගියොත්. So excavating are there but no chance to unload. The process slowed down. Okay? Yeah. I believe you can understand this. So strategizing and planning. I think this is okay. පුතාලා තේරුණාද? තේරුණාද කියපු එක ළමයි? ළමයි තේරුණාද කියපු එක? ඇහෙනවද? Hello? Children, can you hear me? Do you understand these 5 steps? තේරුණාද ළමයි? සද්දනේ බිල්ලු වගේ. තේරුණා කියන්නේ බාහිර පස් කපන්නවත් යවයි කියලා. Silent. සමාධි පුතා තේරුණාද? අහිනවද? කියන්න බලන්න. Do you understand this?
Yes, sir.
Very good. So how many steps are there in earth moving project, earth removing project? There are 5 steps. Yeah. ඇගිලි පහට මේ පහත් මතක තියෙන්න ඕනේ. තේරුණානේ? Excavation and collecting the soil. එක්ස්කැවිට් කරලා තැන් තැන් වල දාලා බෑනේ. එතකොට ලෝඩ් කරන්න කොහොමද ට්‍රක් එකට? You have to collect the soil somehow by means of excavation. So after collecting, you are loading to the truck. Truck means transport. Then transport the soil load, okay, soil load out from the construction site to where? To the dumping site. Okay, from the construction site to the dumping site. To the dumping site. Dump කියන්නේ අතාරිනවා කියන එක. Dumping කියන්නේ අයින් කරනවා. Unloading. Unloading site. තේරුණා නේද? 4. At the dumping site. The practical හිතන්න මේක තමයි. තේරුණා නේද? At the dumping site. Think you are going to plan this. So at the dumping site, unload the soil from the truck. And empty one should go back. If it's a huge project, do you think one truck is enough? You should have many trucks. Just one is not enough. You should have many trucks. So depends on the size of the project. You have to hire, okay, or rent or lease many trucks. Polyme එකක් load කරනවා ඒ කියනවා ඊට පස්සේ තව එකක් කියනවා that goes. So that's how even the transport return also same way. Yeah. So many are gone. Okay, not just one. So depends on the project. මේක අර කූඹිය වගේ මේක වැඩ කරගෙන යන්න ඕන. Backhouse, do you think one enough? No. You have to match with the rate and all. You may have more if possible. Let's see. You may have more backhouse. Collecting. Of course, you have to have more. You know, yeah, because you have to plan accordingly. If resources less, you have issues to meet the timing, the deadlines and all. So loading, do you think only one machine to load? No, because more trucks there. So there can be more parallel loading taken place. Okay, something like this. Do you know any? Okay, good. So then let me rearrange the steps. Step 1, of course, excavate and collect the soil for loading to transport the soil from the dumping site. Step 2, loading the excavated and collected soil to transport. Loading, very important. Okay, loading very important. You have to take this very, very serious. Then transport the soil load out from the construction site. We can call this dispatch. Dispatch, you dispatch it. Okay, dispatch it. Dispatch is a good word. Dispatch it. So after that, unload. This is the dispatch. Unload. Okay, unload. Then return. What? Transport return. Okay. Return what? Transport. Should return. Okay. Full loading. Okay. Truck should return. Okay. Full loading. So this is transport. Return. Full loading. දැනගත්තනම් පස්කා පණ්ඩුනත් යන්න පුළුවන් නේද පුතාලා? පස්කා පණ්ඩ හරියන්න බැරි? Right. ළමයි තේරෙනවද? Can you understand these 5 steps? For 5 steps, each step 1 minute. I will give you 5 minutes to take these processes into your fingertips. Imagine, even you can close the eye, imagine the construction site. There you have to remove the soil. You're bringing machineries, backhoes and excavators all to excavate and collect the soil. Yes, now you do excavation and collection. Why you are doing this? To load to the transport. Okay, so excavation and collection is something like separately being done. Okay, so trucks are coming. Yes, loading taken place. More trucks coming, more loading, then you have to have more excavation and collection. That's why you cannot do excavation, collection and loading together, because in efficient sites, if you do all together, it's difficult. Okay, it will slow down the efficiency. Okay, so excavation and collection, that is going on continuously. So some are loading, okay, to the trucks. Okay, some are loading. Then the loaded trucks are dispatching, moving out, go to the dumping site, unload them. So dispatching is, so loading is one. After loading, we call it dispatch. Dispatch, that's it. Then it's reached the destination. Okay, where the dumping site, unloading, transport after unloading. වෙන කොහෙවත් යන්න බෑ, must come back for loading. වෙන කොහෙවත් ගියොත් මොකද වෙන්නේ? Performance of this earth moving project, the earth moving rate drop. So all the 5 steps. Okay, excavation and collection, loading, dispatch, unloading, return of transport. මතකද පහ? මතකද? ඊට පස්සේ excavation and collection is number 1, the first. Loading second, dispatch third, unloading fourth, transport return fifth. Give me a second. පුතාලා තේරුණාද? Understand? Now you have to speak. Now you have to speak. Privakshan, Puta, tell me the 5 steps of this project. Privakshan. Yes, you can speak. Hello? Privakshan. Can you explain the 5 steps? Hello? Can you explain the 5 steps? Cannot? Ishibar, Puta, can you explain? Very good. How is it? Can you explain the 5 steps here? Anyone volunteer? Rahim, Puta, can you? Can you explain the 5 steps? ඇහෙනවද කියන්නේ ඉස්සරහම? ඇහෙනවද? Hello? විම්සර? කවුරුත් කතා කරන්නේ නැද්ද? ඔයාලට ඇහෙනවද කියන්නේ ඉස්සෙල්ලා? Can you hear me? Yes. Good. So can you remember the 5 steps? Can you remember? Remember means you have to understand this. The 5 steps. Yes or no? මොකද උනේ? Huh? Someone volunteer to speak. Huh? Mohammed, Puta, can you speak? 5 steps. Huh? Arshad? Yeah, Puta, Rahim. Tell me the 5 steps. Can you remember? Okay, text me. Text me. There is a chat. Okay? Text me the 5 steps. Text me the 5 steps. Text me in the chat. Okay? Text me in the chat. මාත් කට වහගෙන ඉන්නද? හා? හ්ම්. Sam Singapura, can you tell me the 5 steps to the class? Can you tell 5 steps to the class of this earth moving project? තේරුම් නැත්නම් තේරුම් නැහැ කියන්න. තේරුණා නම් tell me the 5 steps. Tell me the 5 steps. Tell me the 5 steps. Huh? Very good, Samsingha. Yeah. Excavate and collect, loading, dispatch, unload, transport return for loading. Very good. So, Rahim Puta, did you copy the previous one? Because exactly it's identical. Hmm? That is okay. At least you responded. Yeah. Okay. Only 2. I need some more. Okay. I need some more. Mohammed Puta, tell me. So only 2 know this. Is that so? So let me consider this as a CA, continuous assessment. A little maybe 5% mark I will give for this question. Are you okay? Today I am going to save this chat. Okay. Those who responded to this question, so I will have special consideration. Okay. Those who respond. Today I will save this text. Okay, only 3 more minutes I will give you to text me to make sure that you know what you are texting. Okay, and I will save this. Pirakshan, are you there? Hmm? Puta, it's a good discipline. Nama කියලා ඇහුවොත්, if I call by name, you should respond. That is very important because it is a help for the class, you know. If I call by your name, you should respond. You have to have that discipline. Okay. So I first called by name Piravakshan. He didn't respond. So the class followed the same. That is not very good. So I will take note that time. Okay. So I consider Piravakshan is absent today even though he is there. Time is up. Time's up. Time's up. No need to send anymore. If I ask to respond, at least if I call by name desperately, if you don't respond, you are really lousy, you know. It's not very good.
Sir, are you talking? We can't hear. Hello, sir. Are you talking? We can't hear.
Did you understand those 5 steps, Buddha?
Yes, yes, sir. Understood.
Perfectly?
Yes.
Perfectly. Okay, thank you, Dhananjay. At least you managed to talk. Yeah. So, very good. Yeah. Even I thought of not talking because you are not talking as well. Okay. So I believe you understand those 5 steps. Okay, good. What are those 5 steps about? About earth removing cycle. Removing, the word is there, okay, or even moving. And the cycle, the word is there. Okay, yeah. Because I want to let you one time learning, that's why I'm trying, but since you are not responding, even I'm disappointed really. Yeah. So these are the 5 steps. So can you see, Puta, here, except 1, 2 to 5 are being operated in a cycle. The first step එක අනිත් ඔක්කොම ටික sequence එකකට යන්නේ. But first step is of course important because without collection, it is not possible for loading. So collection has to go ahead. Okay, collection has to go ahead. ළමයි තේරෙනවද? At least you have to say yes. Huh? Yeah,
Yes, sir.
very good. Yes. Yeah. This is practical. Practical. Collection should go on, and the cycle of this operation should go on. Loading, dispatch, unloading, and empty returning of transport. Okay, after unload. This is very important. Yeah. So if one of the steps slow down, okay, yeah, answer these questions. Yeah, let's see. If one of the steps slow down, what will happen to this operation? Okay, so you can consider this as a kind of operation. Okay, this is something like an operation. It's going on sequence of steps of some work is there. Let's say if one step slow down, what will happen?
All the steps are so.
Yes, all steps are slowing down. That's the point. You know, because all are now well fine-tuned, operating or functioning very well. If one step slowing down, all the steps cannot perform. Then loading slow down. Collection, you may have limited space. No point extra collection, maybe for later use, but collection has no effect. If loading slow down, dispatch definitely slow down, unload slow down, returning slow down. If dispatch slow down, what happens? All the steps slow down. If unloading slow down, again all the steps slow down. If the return of transport after unloading, empty return, if slow down, all the steps slow down. Okay. If collection slow down, the process is not effective because without no earth collection in efficient way, you cannot run the operations no matter how well you are prepared. Your system well ready operate, but collection slow. You cannot do anything. Everything will slow down. You ready? So collection should be good for the cycle to perform. Also, for loading to perform, follow me very well. For loading to perform, collection should perform very well and return of transport should perform very well. Pera saha pasu deka. If dispatch to perform well, loading should be good. Okay. And unloading should be good. Then returning good and then loading good again. Okay. So you can feel that all processes are interconnected and all the 5 steps should be in tip-top condition all the while to have the effective earth removing operation. Okay. So you should understand this very well, the practical point here. Yeah, it is very, very important. So separately understanding loading, dispatch, unloading, return, separate knowledge is not enough. You have to have the total process knowledge to have some effective operations overall. Because your bottom line is you have to remove the earth collection faster and you have a destination, you are unloading, that is a dumping site. So you have to fast unload and then come back for loading. Likewise, collection can be removed effectively. So this is very, very important. Okay. And you know the cyclic nature of this. That's why I put earth removing cycle. Okay. So did you understand those 5 steps? I need a very strong yes from you. Okay, that is very important. That is for earth removing cycle. And I no need the term no. So that is very important. Make sure to confirm this. Okay, did you understand those 5 steps? You should be able to say yes for earth removing cycle. Okay, and you have an exercise afterward. Okay, you have an exercise afterward. Make sure to respond to me. Okay, I put this instead of earth. Earth is a kind of matter, heat is a kind of energy. Yeah. Yeah. I will give you 5 steps, 5 minutes. Send by chat. Yes or no. Okay. Send by chat. Yes or no. Yeah. And if you know 5 steps, yeah. Also, you have to put the 5 steps there. So that's why you have learned earth. Earth is very easy, you can see it. Okay. Now about heat removing cycle. Yes. Identify the steps. Once you identify, say yes and chat me the 5 steps. Supposed to be 5 steps. Yeah. I will give you 5 minutes to respond. Okay. I will give you 5 minutes to respond. මම පන්ති 8:00ට දැම්මෙති කයෝ කට්ටිය. Yeah, today is with more dialogues and more challenging. Yeah. So I will give you 5 minutes for you to respond. Yeah. Okay. Yes. Yes. Yes, I received 1 yes. Now only I am seeing it. Okay. Very good. I have received only 1 yes. Okay. So I have to see more yes. Yes. 2 yes I have received. Very good. 3 yes. Yes. If possible, Putana, please put the steps as well. Okay. If you sense it, yes. If you sense it, yeah. 4, 5, yes. Only 4 yes. think bit practically. It is very important. Yes, more yes. Yes. Good. Okay, very good. Okay. Now, today we are learning slow but very steadily. Yeah? Don't worry. Let's say this is your classroom. Okay, this is your classroom. Can you remember? Classroom. Can remember classroom. So let's say this is some cross-sectional view of classroom. Thermodynamics. This is at the third floor, second floor, I cannot remember. Second floor, new building. Okay, second floor, new building. I hope you can remember this. Okay, so there you have a door also. Somewhere, let's see, you are entering from here. Have a door here. Yes, some windows are there as well. Do, yeah, cross section, so should be okay. So there should be some windows also. Somewhere here you can see this side you have windows. Your blackboard is here. Okay, let's see. Yeah, the first one, first one. Yeah. Because later we moved for the non-AC room, but let's say previous one was with AC, air conditioned. You have the air conditioner here. Okay, you have the air conditioner here. So 1 or 2 units here. Okay, so this is the indoor component of the air conditioner. This is the indoor component. Okay. Your air conditioner. Here, there is a fan as well. There is a fan and a coil. Okay. So there is a fan and also there is a coil. The component of the AC. There is a coil, okay, and also there is a fan component as well. Okay, yeah. So this has a fan component of this. And also there is a coil.
So we can't see
Excuse
this.
me, sir. We can't see the
screen.
Ah, okay. So this is your classroom, okay? This is your classroom, thermodynamics, second floor, new building. This is the door and the walls, some windows here. There is a cooling, the AC indoor component. Indoor කියන්නේ මේ කාමරේ ඇතුලේ house. එළිය නෙවෙයි ඈ ඇතුලේ. Component of AC. Here you have, in this indoor component, you have a coil and a fan. Okay, you have a coil and a fan. You have a coil and a fan. Okay, you have a coil and a fan. So this is a coil. Coil කියන්නේ මේක බටයක් මෙහෙම මේ ඔතලා වගේ තියෙන්නේ. It's a ඒක ඔතලා තියෙන්නේ. It's a wound length of a tube. Okay, with fins. So we call this coil. So indoor component, this has a coil. COIL. Okay, coil. Even you can mention coil. This can be a coil of tube. Okay, tubes. Okay, so this is we call the cooling coil. Okay, this is a cooling coil. It's a technical word. Okay, technical word. And this is the fan. Okay. Also, we can call this cooling fan. Okay. Because this indoor component performs some cooling. Okay, cooling. Okay, making the සීතල කරන්නේ කාමරේ. So there is a name for this indoor component. We call this evaporator. That is one name. Okay, indoor component of AC. We call this cooling coil. Also possible. Right? We call this cooling coil. Cooling coil. But cooling coil is here, this one. This is the cooling fan. Okay. Sometimes, because the cooling coil is the major part, we can call this cooling coil. Or the best is we call this fan, coil, cooling unit. Okay. This is the best wording for this. Fan, coil, cooling unit, this one. Okay, fan and coil, cooling unit. Yeah, or we call fan coil unit. Fan coil indoor unit, also possible. Or else we can call this, generally people call this one the indoor fan coil unit. Yeah, that is okay. Yeah, later we will look into some more terms. So what happens is this fan, okay, throws some air towards the students are here, so towards the hall. Yeah, Buddha. Okay. Yes. And you can see using the fan, there is some airflow throwing. Okay, airflow throwing into the classroom, you can see. Airflow throwing into the classroom from the fan. And then this throwing air somehow getting circulated. So students are here. So let's say these are the students. Just imagine. Students are here. And then this thrown airflow somehow getting distributed. We can say, okay, we can say this one. And after that, this thrown airflow will be returning back. Okay, is returning back like this, let's say from down. So it's distributing somehow. This is the replacing of warm by cold media here. It is something like this. Okay, it is something like this. Okay. So you can see the cold air somehow thrown over this students, let's say, and then somehow this hotness or the warmness is taken away and returning back to the coil. Okay, returning back to the coil. So this is very important. So here you can say this airflow management here. Airflow management is extremely important. Airflow management. Okay, it is not just simply putting a fan. So it's a management. So here there is a way of something like excavating. That is through this cold air distribution. And also there is a collection. Okay, collection. is done by airflow management. Okay, collection. Excavating and collection. What? Of heat. Interesting, eh? So the same way in heat removing, you can see in an effective, same like earth removing, in an effective heat removing, you may notice this excavation of heat. Okay, this airflow management. උනාට මේක සමහර අයට නම් රස්නේ දෙන්න සමහර අයට වැඩි සීතලක් තියෙනවා. So airflow management may not be that effective in excavating and collection, but anyway, there is some good effect of excavating and collection of heat. Okay, so for this one, this fan design, here the front, there are louvers for the airflow to move, and some even there are swinging the flaps like, you can swing there. So you can see that is to facilitate this excavation and collection of heat. But you feel like you are receiving cold, but for the system it is excavation and collection of heat. මේ heat එක මේ විදියට එකතු කරලා ගන්නවා, හාරලා එකතු කරලා ගන්නවා වගේ වැඩක් කරන්නේ. So you feel cold. But for you it is you are receiving cold, but there really is excavation and collection of heat from you. Then you feel cold. Okay? Then you feel cold. මේක මේ හිතන්න ඕන දේවල් පුතා තේරෙනවනේ. මම මීටත් වැඩි හොඳට තමයි තේරුම් ගන්න ඕනේ. තේරුණාද? ඒකයි අර earth removing cycle එක ගැන කියලා දුන්න එකම හේතුව මේව එතකොට practically හිතා ගන්න පුළුවන්. තේරුණා නේද? So these are all you මේ ඔලු ගෙඩි තියෙන blue colored circles all. See the 8 students here. Yeah, likewise. So there can be other heat loads, lighting and all. Okay. So airflow management is very important. Excavation. Okay. So now you know in the heat removing cycle, this excavation and collection of heat is taken place. If this is not effective, there are issues of cooling performance. So should be effective. Okay. And then ඔලුව පාවිච්චි කරපුවාම දැන් හිතා ගන්න පුළුවන් in providing a cooling solution how effective this airflow management. So if I am a designer, this is one of the top concerns. Okay, so then you can see this excavation and collection. So how this is being loaded somehow. This return, of course, return, let's say like this maybe. That's how it is going. Flow එක තියෙන පල්ලෙන්නේ. Down and the return is on top. Anyway, it's okay. This is how this return. This is how this return. The return එක තියෙන උඩින් වෙන්නේ. Somehow we can see depends on the different designs. The fan flow is like this. So blowing through the coil. Blowing through the coil. Yeah. So internally you can see there is a flow of air flowing, crossing. Airflow is crossing. Okay, airflow is crossing. Let me try. What happens? This is the airflow. Okay, so airflow is crossing over here. This airflow. So I will change the color of this as well. Yeah, you can see it. Yes, I believe it's okay. Yes. Yeah. Let's see. Yeah, very nice. Okay, good. Hmm. Yeah, should be. Yeah, should be. Yeah. I hope you can understand this. So what you need to know is there are excavation and collection like, okay, taken place here with the airflow management. And then I have to continue this. There is a flow of transport fluid, working fluid. Okay, working fluid. So let me mark with some dark blue. Yeah, this blue is okay. So here, yeah, I put it here. And then there is a return. Okay, there is in and out of working fluid. In to understand very well. In out. So what has happened is, so this is the cooling coil. This is the cooling coil. So what has happened is, when air passes through the coil, and here in is cold, means ready to receive heat. In ready to receive heat. Flow in, ready to receive heat. Let me move this a little more. Ready to receive heat. Flow in. Okay. Flow out. Okay. Loaded with heat. Loaded. With heat. Or we call this heat laden. Okay, heat laden. Now laden. Yeah. Okay, loaded with heat is okay for you. Flow out. So that's how the loading is taken place. Okay, loading is taken place. Flow out. So flow in, ready to receive heat. And actually, this is the transport return. Return after heat unloaded. Okay, transport return after unloading heat. Okay, by right, this should be the way for the continuous removal. That's why this is in cycling continuous. So flow out. Okay, unloaded, the empty returning transport to take the heat or to load the heat, and then after loaded, it's out here for dispatching. For dispatching. Okay. And there is another unit connected to this. Okay. There is another unit connected to this. We call it Compression. Okay, Buddha? Compression. So let me take a compression. Yeah. So I will draw the compressor here. Let me put this little bit like this. Okay. Okay. And there is a compression. So let me draw a compression. You will see this compression in your household, means your refrigerator at home. You see this black color one. Compression. So this is the pumping machine. So this effect of compression, really this sucks. This is suction. And then after that the compressed goes out. So this is a suction. So let me draw this. Compressor suction is here. Yeah. Let's see. This is compression. I just put as compression here. This is what we call dispatch. By means of this has the power to dispatch.
நீ கொஞ்ச நேரம் ஹிட் பண்ண அது வாப்சர் நீங்க நான் நீங்க ரெண்டு மேட்ச் வின் ஆயிடுறாரு அப்படிங்க நடிக்காம வாப்சர் 3 பவுண்டரி வாப்சர் நீங்க கண்ண அடிக்கே இல்ல 3 பவுண்டரி அடிச்ச வாப்சர்.
Okay, this is the dispatch. Okay, now you can see the loading here, the excavation and collection, loading, dispatch. So after that, later we will talk about the strategies behind this. After that, this goes to the unloading site. This goes to unloading site. Okay. I will just connect it here. Because even unloading, there can be a fan to throw the air, to use the air to throw the heat out. So the airflow, okay, airflow. Here, by means of airflow, then in, out. I just put this way, even this can be the other way. Yeah? In, out. So out, I will just put more warmer one. More warmer one. Yes. Unloading heat. Okay. Unloading heat. Quite interesting. Unloading heat. Unloading heat taken place at condenser. Later, we will learn what are these components and why these components are necessary and in what kind of technologies we are using this. Okay, unloading is taken place. So, same here, I will take the dispatch here, the major word, dispatch. So, unloading. Then, after unloading, there can be return. Okay, there can be a return. Unloading through the air, you can see. Okay, unloading taken place. So here you can see the return. Okay, return. Very nice. I need to take some space here. That's one. So this is here. Should be a bit noisy Buddha here. Sorry about this. Right. So here is the flow direction. You can. Here is the flow direction. So I will group these arrows. And I will format this. Good. Ah. Okay. Good. Yeah. Okay. Flowing. Okay, ready to receive. So there is another component here. Okay, to unload a return, there is another component, we call it, yeah, let me put something for that. Let me put something for that. Let me put something. This is very important piece here. We call this a metering device. Okay. Only after metering device is ready to receive. Okay. So this is the metering device here. So let me take some space. This is the cooling coil. Bit noisy today, bit noisy. Yes. This is flowing. Good. And this small piece we call metering device. Later I will explain you why metering device is there. Okay, why metering device is there. So it's a capillary now. Or we need expansion valve. So I just put XP valve. Or as metering. What metering? Flow metering. Okay. Why do we need to meter the flow? Metering means flow control. Okay. Flow metering. Metering means control. Okay. Flow control. Because compressor, this dispatch has a very high dispatch power or pumping power. So controlling of pumping power is only by means of this. This metering device can control the flow, not the pumping power. Even though this can make a huge flow here, this metering device control it. So we have some differences in pressures and temperatures. Later we will discuss this. So you can see here, excavating and collection of heat. So that's what I need to highlight. Collection, dispatch here. Okay. Okay. Actually, heat is being dispatched, but you cannot simply heat because heat in the refrigerant. So those are some important arrangements. So refrigerant or the transport is being dispatched. Unloading is taken place here. Okay. And then after unloading, return. This is the return of transport. Okay. Transport return. Okay. After unloading heat. Say after unloading. So step 1, excavation. So this has been taken place. And here the loading is taken place here. So this is where the loading is taken place. To load heat, for loading heat, for heat loading. Okay. So I will use this. Loading is taken place. Okay. So 1, 2 is loading is taken place. 3 is dispatch. Lesson के कोहिंगा तीन घंटे नहीं बाटी होता है. 4 is unloading and 5 transport return. 5 transport return. Okay. 1, 3, 4, 5, and 2. Yes, 1, 2, 3, 4, 5. So I put the airflow management here. Okay, this is the class row. Okay. So this capillary or metering device is placed quite closer to here. That is good. Okay, quite closer to this cooling coil or heat loading, where heat loading is taken place. Okay. So indoor unit. So this metering device is quite closer to that. But since I need to put here this return after this, okay, for this is responsible for the transport return. Capillary is responsible, or metering device is responsible for transport return. So I put this to combine. Okay, I put this to combine. Okay, good. Let me put a dash line for this. Good. Fan coil unit is here. Heat removing cycle. You can say yes. Good. So to digest this, I will give you 5 minutes or take a break even. Yeah, we will take a 5 minutes break. Also, you can think about this. So see you in 11:40, yeah, 11:40. විනාඩි 5ක break එකක් ගන්න පුතාලා. I know. Why only 28 now? Who left? Then again, unless no reason. Okay, you should try to understand this, because even I'm trying hard to let you realize this with some simple natural examples. Okay. In earth removing process, okay, cycle has only 2, 3, 4, and 5, and 1 is of course happening all the while. 5 steps, but cycle has only 4. Cycle for loading, dispatch, unloading, returning. Okay, so same way here for the cooling cycle, you can see loading take place, dispatch takes place, unloading takes place, returning takes place. But airflow management or excavating and collecting, excavating and collecting. So this is a separate art and science and technology together, the step 1. That is very important. And for the cycle 2, 3, 4, and 5. Okay, for the cycle you can see 2, 3, 4, and 5 for the cycle. So if I draw here, if I draw here, one, okay, 1, one is here, then comes 2, because you are familiar now. Afterward will be 3, then 4, and another one 5. Okay, after 5, how the cycle completes? Back to 2. Okay, that will be back to 2. Okay, that will be back to 2. 5 to 2. Okay, 5 to 2. Okay, 5 to 2. That's all. Okay, 5 to 2. So that's how the cycle. Cycle. 5 steps in the cycle. Cooling cycle. Okay, 5 steps and the cooling cycle. Okay, you are familiar with the cooling cycle now. I mean the strategy of operations. I yet to know the cooling cycle, but you know the strategy very well now. Okay, you know the strategy very well. And me natural understanding එක නෑ කියන්නේ. You cannot understand the cooling technologies. Okay. So now you can see 2, 3, 4, 5. Okay, 2, 3, 4, 5. You can see. But when it comes to application, one will come to place. Okay, together with your classroom here. Okay, together with your classroom. Okay, good. Then, so I draw the key components here. And I draw myself this one also. Bit noisy today. Dispatch, unloading, this one I put as Indo. This schematic I show as Indo, and I name it evaporator. Later you will learn why this is called evaporator. Okay. Understanding, very important. If you cannot understand this time, it is very difficult to understand afterwards. So pay your attention very well. That is very important. So in the cycle, of course, operation 5 steps. But when it comes to cycle, 4 steps, 2, 3, 4, 5. Okay. So each and every step has major components. Dispatch, it has its own component. Unloading, own component. Then in the return to condition this, empty return conditioning the transport. කුණුවරම ඔක්කොම අයින් කරලා සුද්ධ කරලා හොදලා ගේනවා කියන්නේ අන්න ඒ වගේ. So the metering device is there. Okay, metering device is there. So that's how it's controlled. And then of course the loading taken place here. So you can see loading taken place. We call it evaporator in how to say, in a cooling technologies associated with working fluid of refrigerant by nature. Okay, so here evaporator. I put it here, the evaporator. Now the compressor later I will tell you why we are taking these components. Unloading, heat, condenser, and here the transport returning is this one. So the flow direction you can see from the arrowhead. See? So between the dispatch and unloading also there is a direction from dispatch to unload. Okay? I believe you can understand this very well. And you can see here in this process the transport. Okay, transport is very important. With removing, transport tama the collection, of course, dispatching, you have the places and techniques, but wherever transport is involved, transport. We call this working fluid. Why we call this working fluid? Transport associated with working fluid. Working fluid plus something. Okay, transport with working fluid. Okay. So example, compressor is a component associated with the working fluid. Heart. Blood is the working fluid. So heart with the blood is here. So compressor with working fluid. So condenser. Okay, unloading. Let's say unloading. This may be the cell level or whatever. Let's say this is an organ. So goes here. Okay, for here, this refrigerant or working fluid goes here. Okay, goes here, and then the heat is being unloaded and then returning through the capillary back for loading. So 4 major components, and you have the working fluid. So noticing the presence of working fluid is very important. Okay, noticing the presence of working fluid is extremely important. So without working fluid, you cannot perform this. Okay, without working fluid, you cannot perform this. Okay, understand? Yeah, this is very, very, very important, extremely important. The understanding of the working fluid. So based on the type of working fluid, you may have specific designs, but somehow the 4 components for the 4 steps for this working fluids is like this. Okay, it's quite interesting. So we call for these 4 steps corresponding 4 components, we call 4 major components. Okay, 4 major components. There can be other components, they are not major. 4 here, for the 4 steps, we call major components. There can be other components as well. Okay, 4 major components. So we compression system, this one, working fluid is there, later we will discuss. So these are the names of the 4 major components. Okay, just have a look on this, later we will get more familiarity. Okay, later we will get more familiarity. So I'm going to share with you one more slide now. It's same like the previous one, but little bit, how to say, more refined. Okay. So I take this out and I put that here. This one. Oh, sorry. No, it is. Yeah, let me put it again. It's the same. Okay, it's the same. But here, let me put this way. It's the same four major components. But you can say here, so you have a fan, okay? Here with your cooling coil, this may be your classroom, okay? Your classroom may be this one, classroom. This may be your classroom, okay? The walls and all, but I just put this in little bigger way, okay? The fan and the coil. The four major components, your evaporator or the cooling coil together with fan, okay? Because you know this, compressor is here, condenser over there. This is where the heat is unloading and this is the return. Okay. The very first one you can see. Actually, this is from this drawing is from an original design. So this is one load. Quite nice. So the condenser fan is here somehow. Is fan is placed here. Okay. Yeah. Others. Dispatch. This is your dispatch. Compression. Okay, that is your dispatch. And the number 2. Indo component of, I put it AC, that is all right. So this is the Indo component, cooling fan and coil. Okay, cooling fan and coil unit. So this is the one. So you have 3 here. The fourth one is for returning. It's the same. So you can say this. So classroom is here. Okay, classroom. Okay, I hope you can understand. And if you are looking into one more, let's say this is not a classroom. This is a cool room for vegetable, or let's say this is refrigerator, a big one. Then if this is the refrigerator, formed body means this is the insulated body. Okay, insulated body, this black, this rectangular shape you can see, insulated body. Inside is the cooling coil, and there can be fan even though you do not see this. Bottom you will see this component, and sometimes this is not be seen as like this. This can be in different forms, but still unloading is taken place and condenser is there. So there are this kind of components, and then definitely you can see this. Okay, capillary. So in household refrigerator. Okay, even in a bottle cooler in a small shop, still you can see this. So the 4 major components are here, incorporated with necessary fans here. So for the evaporator there is a fan, because you know that for the excavation and collection of heat, fan is important. Even for unloading, when you blow air through this, fan is important. Okay, and here you can see again the refrigerant. The transport. It is very, very important. Transport or working fluid is here. Yes. Working fluid is here. Okay. Working fluid is here. So working fluid passing through this component, through these components. Let's say after dispatch, it goes through this unloading, through the metering device, back to this loading point, and then come back to dispatch. Then for unloading. So the refrigerant or the working fluid passing through these 4 components. 4 components. Okay, passing through this 4 components. Hope you can understand this. Passing through these 4 components, and this fan is for this excavation and collection. Okay, and this helps for loading as well. Loading. Because this force the air flow through this. That's how heat transfer from air to the cooling device here, or evaporator, whatever cooling device. See the coil, you can see the pipes, end pipes, you can see the U-turned or arranged as a block of coil. This is a single tube most likely. Very long one, put in a coil way. Okay, we call this coil. So this is namala arrange karla thiye, something like a coil we call. Yeah. Okay. It's 12:10 now. So these are the key things. You know the 5 steps, and you know the 4 major components are there, and of course step 1 is taken place separately. You know that as well, and you know about the working fluid, and flow this working fluid through each and every component, the 4 major components, and the functionality is taken place: dispatching, unloading, return, and the loading back. So without working fluid, this will not work. So working fluid is very, very important. Okay. And I'm going to share with you a new slide. Heat removing cycle, it's the same. But you have to look into this very carefully. Yeah. Small text. Collecting the heat. So collecting heat from the space. Space is your storage area. I mean, we are refrigerator inside. So the collecting, excavating and collecting, step 1. Step 2, loading heat into the transport. Okay. Then after loading, dispatch the heat loaded transport to outside. Then reaching this to unload, okay, at the dumping ground. So this can be ambient. Okay, after that, transport is returning transport. See the capillary. So loading bay, the loading of the heat, evaporate, dispatch at the compressor, unloading at the condenser, returning at the capillary, and this collecting and loading separately being taken place. This is the airflow management. Okay, airflow management. So even this bottle cooler, the technology, it follows the same. Okay. So I think you may understand this well. Okay. Then cooling cycle again, collecting the heat, air circulation, no interaction between storage area and evaporator, collecting the heat. Actually, I have constructed this, loading the heat, evaporator, loading, dispatch, compression, unloading condenser, transport, return, we call the capillary or the metering device. The cooling cycle, 5 steps: collection, loading, dispatch, unloading, empty returning of transport, that is capillary or metering device. Good status of 5 steps or cooling cycle: heat collection to be good, returning transport should be good, collection should be good, loading should be good. And collection කියන එකට පෙර සහ පසු steps දෙක. For loading to be good, the other two, collection and dispatch, should be good. Dispatch එක slow down load වෙන්නේ. Okay, because the transport or refrigerant has to wait. Dispatch should be good. The before dispatch and after dispatch, loading and unloading should be good together with dispatch. Unloading good means dispatch and return should be good. So empty return to be good, loading and collection should be good. So good stages of cooling system, all the 5 steps should be in well meshed fine condition. Okay, so the transport, the refrigerant. Okay, transport is the refrigerant or the working fluid. Okay, heat collection, transport involvement means for the loading, yes. So even for collection of transport, I would say no here. Loading, yes. Dispatch, yes. Unloading, yes. Returning, yes. Collection, some cases yes, some cases no. Okay. Anyway, refrigerant is very important. Okay. So this is somewhat, I've developed this for some different presentations in 2014. Okay. So yeah, I'm not going to discuss everything. So this is to preparation, the background to understand refrigeration. And there may be very interesting, not here, there may be very interesting things about refrigeration. Let me share with you. A very old refrigerator advertisement is here. Brand is McGray. Okay, so this one is so aligned with porcelain tiles. Make a porcelain tile ගහලා තියෙනවා. The frames hadala, these refrigerators. Now different. So this is an advertisement. So this is a very old one. This is a General Electric refrigerator. This is 1927. This is the compressor here. But this has very value, big value for this. Now General Electrics, this may be still working, but those are, see, inside. This is the first refrigerator with the compression. These old dumps one, old fridges. See, insulated bodies and all. That's why refrigeration, cooling systems, cooling technologies has some environmental aspects as well. So later we have to consider this. Some systems, so some innovative solutions. This for fruit. There's a concept designs, LG. See the solutions those days. These are some adapting of some maybe different usage of the, see the safety issues we have for the refrigerations, some new designs. So these are different designs, because cooling system applications are plenty. This is a basic freeze application. This is, we call the, how to say, the absorption refrigerator. Behind is like this, but quite expensive unit. Display cases, you can see. Old refrigerations powered by kerosene. So it's a big advertisement those days, latest technology. Electrolux brand, yeah, run by kerosene. Quite interesting, eh? See this recycling, or the old refrigerator bodies they use in this way. See, fridges are here. See all dumped refrigerators. Some are using for different applications. The recycling. This is a refrigerator body again converted. These are some, yeah, new compressor systems here. That's why, see, the fan and condenser is here. Fan and, this is for the, fan and condenser is for the unloading. The dispatch is here. Unloading, you can see the capillary joining here, but it's not clear there. So some smaller ones, Electrolux. Concept design, see the temperature all displayed here. Another technology, yeah. This one just I gathered those for some design concepts. That's all. And here in this, I have created a checklist. We call this I know checklist. I have created this for different training purposes. So I know checklist. So if someone knows everything, he knows something about refrigeration. This I know technique. I know checklist for the cooling appliances designs. So this one I have prepared this. In 2014. This is my first name. So some awareness training. So that's all Putana for today. Because we had a very strong start. So happy to know that you know the 5 steps. Yeah. So we can learn, we can gain a very strong knowledge. So yeah, even some questions are coming, technical questions, Putana. Yeah. Fixing, changing the compressor front AC to dual AC. Yes, here you may have little issues about the engine power because the power is taken from the engine, Putana. So you have to balance only that. If your engine is somehow powerful enough, or if you can balance it, or if you can have more efficient solution, still you can have dual AC. So we will discuss this later. And let me put some more little things here before winding up. I can see 29 students are here. Yes, if we think of energy, okay, energy interactions, give me, yeah, till 12:30 should be all right. I will use the same arrow here. You can see here, after collecting, heat is loaded here. Okay, heat is loaded. Nice. This heat can be from outside, because always heat load can be from outside to inside or through the walls or through insulations. This is some heat leaks also possible. This being removed here. Okay, this is being removed because everywhere can possible. Heat leaks. So all heat leaks even from the floor, and also there can be heat generated within. Okay, even there can be heat generated within, because the students, they are live, so there can be heat generated within. So all the heats collected, that's why excavation and collection is important, and load into the evaporator, here we say. So after loading this, okay, this heat after loading flow through the pipings, come to the compressor, the same heat. See, it's coming here. And also this, since there is a motor inside, there is little, not to say little, there is a heat generation inside as well. So the heat come here, okay, heat come here, heat generated here, and of course this compressor hot means there is a little heat removal from this compressor to the environment as well, little loss. Okay, and all the heats finally unloaded here, unloading. And then here, after unloading heat, the transport goes back through this capillary. Okay, and not only that, heat generation, there is a work done. Okay, there is a work done on the compressor. W, let's say, there's a work done. So this work also converted to, because of this work done, temperature goes above ambient. Okay, goes above ambient. So your surrounding is important. Your surrounding. So that is outside the system. The surrounding is important. Okay, the surrounding. So let me put the surrounding. Yeah. Yes. The surrounding is very important because this surrounding is very important. Example, if the ambient temperature is high, let's say 30, this, to unload the heat, the working fluid must have a higher temperature, something like 40. Let's say that high temperature can be gained by the working fluid because of the compressor work. This compressor makes that working fluid temperature high. But finally you can see all the heat, all the work, everything turns to energy, or the thermal energy or heat, finally unload here. Okay, finally unloads here. So let me explain this in the next Friday session. So this is, we call the energy balance. And we will talk about the efficiency of cooling systems. Okay, this is just a beginning only, learning, just a beginning only. We will be learning one or two sessions we have to learn in cooling technologies. Then we will go for the power plants. පොතේ මේවා එකක්වත් නැහැ පුතල් නේ පොතේ නිකන් ඔය බලන්න පොතේ මේ කියලා දීපුවා එකක්වත් නැහැ. ඔව් පොතේ තියෙන වෙනස් විදිහට but you have to go through the book as well. Okay, you should go through the book as well. So let me explain this heat flow afterward. See, different heats all pass through the, all loaded to the evaporator or the loading bay, loaded to the working fluid, come back to the dispatch point. It's powered by electricity, and then this all the energy laden refrigerant or working fluid to transport, dispatch, and reach the unloading place that is outside, of course. They unload the heat, and then the refrigerant or the working fluid return empty with the right temperature levels for reloading. Okay, that is very important. පුතා මේවා ගැන හිතන්න ඕන. තේරුණානේ? දැන් තියෙන්නේ මේවා ගැන කල්පනා කරන්න. You have a lot of things to think. Okay? කල්පනා කරලා බලන්න කොහොමද මේ ටික තේරුම් ගන්න කියලා මේ කියන දේ ටික. So 5 steps. In the 5 steps, 4 steps are in a cycle. Corresponding to each step, there are components. And transport is a kind of refrigerant here. And the step 1, you know the airflow managements. Collection is taken place. Excavation and collection. ඔක්කොම heat එක ගන්න ඕන. තේරුණානේ? So that's how it is. So I believe you should feel good today. උත්තර දුන්නේ නැති එක විතරයි කරපු වැරද්ද. But anyway, next time you should respond. So this basic understanding is enough for you to go through the refrigeration section in your texts. Also the previous lesson, PV equals nRT and PV equals mRT, and van der Waals equations. I believe you have some knowledge. Okay, you should go through this, and these notes are really helpful for you. Okay, මම නිකන් පොත කරලා වැඩක් නැහැ නේ. මොකද මම දන්නවා ඔය කට්ටියට ඕනේ knowledge එක මොකක්ද කියලා. ඔය කට්ටිය එක දන්නේ නැති වුණාට. What kind of knowledge you need? කියන්නේ Tamanට knowledge එකක් ඉන්න ඕනේ මොනවා හරි දෙයක් develop කරගන්න. තේරුණාද? මොනවා හරි අලුත් solution එකක් දෙන්න. System එකක් develop කරගන්න. Innovation එකකට. ඒවට ඔය පොතේ තියෙන ඔය සමීකරණ වලින් කරන්න බෑ. ඒ වුණාට සමීකරණත් වැදගත්. තේරුණානේ? පොතේ තියෙන ටෙක්ස්ට් එක කියවලා you cannot learn refrigeration. තේරුණානේ? The textbooks are like that. But to learn refrigeration, you have to hear from the expert people. Even I have over 10-15 years of experience in very good cooling technologies, not only cooling, even heating, thermal sciences. We have some good experiences. So we know what to share with you. ඒකයි මේ මෙච්චර මහන්සි වෙලා මේ වගේ ඒවා කියලා දෙන්නේ තමන්ට මොනවා හරි වැඩක් ගන්න මේ ඉමේජිනේෂන්ස් එක හරි මේ ඉන්ට්‍රස්ට් එකයි එක්ස්පීරියන්ස් එකකුයි ගන්න. තේරුණා නේද? නැත්තම් මෙච්චර මහන්සි වෙන්න ඕනේ අපිට දැන් අද පැය 4ක්නේ. ඒකනේ මෙච්චර මහන්සි වෙන්න ඕනේ නැත්තම් go to this, go to the notes, look into this page number this, go to example or take the question number 1, it says this, how to solve this. Even I can show you how to solve, and then I can give a similar example, and then you will go to the exam and you can get a pass. මොකටද? ඒකනේ හිම ගොඩ යන්න බෑ. ඒකයි මං කියන්නේ. එහෙම ගොඩ ගිහිල්ලා නැහැ කවුරුවත්. ඉතින් ඔය කට්ටියට හොඳම subject knowledge එකක් ගන්න opportunity එකක් තියෙනවා. So this is a very rare opportunity. So take this opportunity and learn this. Okay? You have to respond whenever I ask something, because I know that today 5 steps are very important. To fail it and to have in fingertips. Even I will ask those in the exams. If you all the batch is silent, even I'm disappointing, you know. That's why you should respond to me. Okay, you should respond to me. So that is very, very important when I ask, especially if I call the name, call by name, you should respond. It's a good discipline, you know. So today, Piravakshan, Puta, you didn't respond to me, so that is not good. So next time you should know how to respond. If you cannot understand, just tell that you have some issues in understanding or anything. You can text at least. So have that good discipline. Learn this. Learn the subject. Okay? Thermodynamics is a wonderful subject. Without thermodynamics, no current solutions possible. Even your smartphone, the technologies involve thermodynamics. Yes, even in future nanotechnologies, even now pico technologies are coming. Thermodynamics are there. හිතන්නකෝ silicon, silica, valuing, smartphone එකේ තියෙන ඔය semiconductor items ටික හදනවා නම් valuing. ඔය value වලට මතුරලා නෙවෙයිනේ ඔක හදන්නේ. You have to heat it. You have to cool it. There is a process. Heavy thermodynamics associated chemical processes. Putting ඉගෙන ගන්න බෑ. So you have to build up your interest on this. Okay? So that's why I'm explaining in this way. So this is about the cooling technology. Similar way. See, even we have learned from the balloon example, a very nice approach to naturally learn the closed systems, PV diagrams and all. Now today, through this earth moving example, we approach the cooling technologies. So you know now you know what's the strategy, the 5 steps. And in 5 steps, there is a 4 step in a cycle. And you know how to make it good. You know that how important to have the well matching of the 5 steps. If one step is not performing, the system is not performing. You understand this? These are the important points. You know? Yeah, that's why. So once you understand this cooling technologies very well, we have to go for 1-2 sessions more. Then for the Power plant application, you will know the things very well in and out. And you will do some questions also, some calculations. It is nothing because steady flow energy equations, we have done it. It's a matter of only applying. So you have very sound knowledge to further carry on your technology learning in thermodynamics. That's why. So please be serious, Putala. That's why even I'm putting a huge effort on this, how to pass this knowledge to you in this non-face to face. Zoom එකේ දැන් ඉන්නේ. පන්ති හිටියනම් මෙච්චර දඟලන්න ඕනේ නැහැ. හරිම ලේසියෙන් මේක උගන්වන්න තිබ්බා. Because you are not talking and I'm just talking to the screen. So I have to make this full effort for you to understand this. Okay. At least I'm happy if you know the 5 steps today and a little bit more about that. Yeah. And the importance of matching the 5 steps. Yeah, that is good. So imagine we spend 4 hours here with 5 minutes break. So that's how when we are learning, it is really tough when we are sharing a good knowledge. Eh? So that's all. Okay. Before winding up, any question? Any question, Putana? Any question? I gulu vela. Okay. Is it okay if we go for an extra sessions? Extra session එකක් දෙකක් යනකොට කැමතිද ළමයි? පුතා? ඇහෙන්නේ? ඔව් කියන්න බලන්න. Is it okay?
Okay sir.
Okay නේද? ඒක තමයි පුතා කතා කරලා අපි extra session එකක් දාගමු. එතකොට මේ විභාගෙ කියන එක නිකන් nothing toys වගේ ලියන්න පුළුවන් විභාගෙට. හොඳ subject knowledge එකක් ගන්නත් පුළුවන්. එහෙම වුණොත් manufacturing mechatronics ඔය දෙගොල්ලම කතා කරලා මට time එකක් දෙන්න. රැට උනත් කමන්නේ. That is okay. Any time you feel good, but Monday, Tuesday and Wednesday afternoon I am busy. I have lectures. Okay. Thursday generally we have meetings. So Monday, Tuesday, Wednesday, except afternoons I'm okay. Afternoon only 2-3 hours, that's all. So Friday we have the normal class. Saturday I have for B2 another session. Saturday afternoon. So any other times it's okay for you. I will spend my time for you if you can arrange the timing. පුළුවන් පුතා කතා කරලා දාගන්න බලන්න. තේරුණා නේද? දාලා ටිකක් මේ ප්‍රශ්න අහලා කටවල් ඇරලා මේවා මේ විශ්ල ගන්න ඕනේ ඒවා. තේරුණා නේද? ඔව්. එහෙනම් කතා කරලා මට ටයිම්ස් දෙනවද? පුළුවන් පුතා.
Okay sir.
ඔව් නේද?
Okay sir.
හරි. එතකොට we will try to have some extra session at one extra session a week. ඒක very nice පුතා මේක හරි ලස්සනට ඉගෙන ගන්න පුළුවන් මේ subject එක. ඒකයි. මම උනත් බලන්න කියලා දෙන විදිය on the spot I'm generating the notes, figures and all because we have experiences. So you have to receive this knowledge. ඒකයි. හරි පුතා එහෙනම් මේ බලලා මට extra times ටිකක් දෙන්න බලන්න. representative ලාට කතා කරලා මට call එකක් දෙන්නකෝ. හරි නේද? Right. Okay. So then let me stop the class. Good luck to you all. So take good care. අපි හින subject එක කතා කරමු. Extra sessions කීපයක් දාගමු පුතා. Good. Because this is a very sweet subject. At least you should understand the sweetness of this. This needs little time. Right? Oh. Okay. Right. Okay, Putala then. Thank you very much. So take care all of you. Bye then. Bye. Bye.
Thank you sir.
Thank you sir. Thank you.
Bye.